Okay, so we're going to try for a bit of a crash course in IGCSE core set notation, definitions, Venn diagrams. Okay, so let's just start at the beginning. So a set is a collection of things. Okay, so just a group of things. Elements are members of a set. Okay, so a group within a bigger set. So a school could be a set of students, and the students are elements of the school. They are elements within that set. Size of sets. Okay, this has notation NA, where A is the set and N is talking about the number of elements within the set. The universal set, U or squiggly E, contains all the elements under consideration. So, for example, we could say, right, how many numbers are there that are even in the integer values? The integers would be the universal set. Okay, the even numbers would be elements of that set. Okay. And that brings us nicely into subsets. The even numbers are a subset, a smaller group within a bigger group. Okay, so a smaller group, a smaller set within a set, a small set. It could include all the elements of a set, or it could include some of the elements of that set. I'm just going to jump down to empty and null, because the empty or null set, that's the sign for null, or some curly brackets is a sign for an empty set, is a subset of every set. Okay, so you can always have an empty set within any, you can have an empty group within any group. Okay, it's like the number of friends that I have, for example. The complement of a set is everything not in a set. Okay, so all of these definitions are on pages, I think, 60 and 61 in the core textbook. You should definitely head to those to have a look at those. All right, so the next bit, we're going to have a look at set builder notation. On page 6 of the textbook is this, okay? It's all the pictures and definitions and things you could ever need, all right? So I would, if you don't know them by now, you must know them, okay? So the first one we'll look at is these curly brackets, okay? The curly brackets means the set of values, okay? If you see them, we're talking about the set, okay? So that is a mathematical way of saying it. This line, okay, so it's on, you can have it on your keyboard. The line, it means such that, okay? It's a way of separated, like shorthand. Okay, so there is a symbol that I can't find to type, but it looks like an E. It's this one here. Okay, it means an element. Okay, so I'm going to give some information below, and you must also know all of these. Okay, so you need to know what type of numbers you're dealing with. Is it the integers? Is it the natural numbers? Is it quotients? Are they real numbers? Okay, and you must know those definitions. So here, let's deal with the natural numbers. Okay, so if we look at this, if I'm translating this into English, it's going to be, I'm looking at the set of numbers. Let's call it A. So A is the set of numbers so the set of values x, such that x is greater than -3 and x is less than 6, and x belongs to the natural numbers. Okay, I know there's a lot going on there, but simply, if I want to write the elements of A, okay, they are the set of, well, I can never draw it, I should, no, I've practiced for years, but I can never draw that one. Okay, natural numbers, the natural numbers, positive integers and 0. So x is between -3 and 6, so we've got 0, 1, 2, 3, 4, and 5. We don't include 6 because it's less than 6, okay, so that's, these two things represent the same thing, okay? So you should now be able to have a go at probably exercise 2A on page 61, 62 if you want to have a play with that. All right, next. Venn diagrams, really important. This is a picture of a Venn diagram. It's got several things, okay? So this area here, this blue area, okay, is defined as set A. If it's inside that circle, then the thing is an element of A. This area is set B. This area contains the set of values that are in set B. The large area, all of it, the green area, including the outside bits of A and B, is the universal set. Okay? So that was one of the definitions we gave earlier. That is dealing with the elements of that big set. Right, it's got two symbols. You must label your universal set as either E or U. You must always have a universal set. Okay? So we're talking, and these, another word, that, so the blue area, okay, is called a region. And so is region. Okay, so the universal set, the area inside the rectangle is the region that is the universal set. The red area is the region of set B, and the blue area is the region of set A. Okay, you should be aware of all of this, but this is a crash course. So, the union. The union has a symbol, so it's a curly, so straight sides and a U. So if we do A unioned with B, we're talking about all the elements in A, unioned, joined with, combined with all of the area of B. Okay, so we're looking at everything together. So I can't shade it any neater. The intersection. Intersection is like the union symbol, but it's upside down. So the intersection of A and B is where A and B cross over. So the intersection is a subset of the union. Okay? So underneath we've got a few things that complement. So you're going to have to get used to the notation. So the complement of A is the region. Actually, let's just change colour. So the complement of A is the region that is not A. So this area is not A. This area is not A either. So not A is everything that's outside A, like it's the negative of A, the not A. Let's say A unioned with B complement. So everything that is not A unioned with B. Well, if above here, if we've got everything inside A with B, this is everything that's not A unioned with B. Okay, and then the only other one that you might come across when you're dealing with complements is something like, how do we describe that section? Okay, so this is B intersecting with not A. I'm going to leave that one with you to have a play with, okay?